Hello everyone, I'm Shan and presenting our work on predicting the behaviors of basketball players from the first-person videos. Let's take a look at this basketball video. This is the NBA final this year, captured by a cameraman who panned the camera around the court. State-of-the-art computer vision systems operate on such third-person videos and predict the player's future. However, this is not how the players behave. In the game, a player sees other players from his own perspective view, such as this first-person video, which encodes how the camera viewer interacts with other players. In this paper, we use a collection of such first-person videos and output the player's future location and gaze direction. It's the predicted joint attention on the court. Attention on the first-person images. We use two first-person visual cues to predict the player's movement. First, the first-person image encodes physical connection. From the distance and orientation of other players, we can recognize the game context. We learn such game context from first-person images. We label the game context by recognizing players using their 3D locations. The bounding box and its color represents the location and orientation respectively. This labeling is fully automatic, therefore scalable, using structure from motion. We use the learned visual semantics to retrieve per-player trajectories and visualize the results here. Physical connection predicts per-player trajectories independently. However, to predict the group behavior, we need to consider all the players as a whole. During the game, the players always engage to joint attention, which is the location players pay attention to. We use the joint attention to consolidate the individual trajectory prediction. There are two ways to compute the joint attention. Geometrically, it is the intersection of the gaze direction. And statistically, it is the function of players' team formation. Ideally, the two locations of joint attention must agree. We define a measurement called social compatibility to evaluate the alignment between the geometric information x and g and statistic information s hat. This can only be done from the first-person view. These two cues allows us to predict the player's future as a whole. We evaluate our method on missing data prediction, where we predict one single player's future given all other players' ground truths. We compare the location and gaze direction arrow with state-of-the-art third-person methods, such as vanilla LSTM and social LSTM, and outperforms all the baselines. We also evaluate our method on group behavior prediction, where we predict all players' future as a whole, and outperforms all third-person baselines. We apply our method to diverse basketball scenarios. Again, the blue trajectory here is the predicted trajectory, while the red points correspond to the predicted joint attention on the court. We apply our method when the players are marching from one side of the court to the other side, when the players are organizing an attack, and when the players are making a shot. Our prediction aligns with the ground truth motion consistently. Please come to the poster section for more details, and thanks for your time.